Hello friends, in my this video I am going to discuss about parasitic number in MATLAB. Okay, so this is also very interesting program, and this program also I am going to solve using the digit extraction concept in MATLAB, whatever I have discussed in my previous video. Okay, so please go through the link given in the description and try to understand how you can extract digits from a number in MATLAB. If you are able to understand that, you can solve this particular problem easily. So now let us directly go to problem statement and try to understand what is parasitic number. So the question says test whether the first input x is an n parasitic number or not. So x and n, there are two inputs for this particular program, and see, like example, here you can create this kind of function named parasitic also, but I will show you normal method and I will post the function code. Okay, you can check there, same obviously, but just instead of directly taking input you have to write in terms of functions. That's all. So see, parasitic of 128205, this particular number comma 4, if these two numbers you pass through the function called parasitic, then output should be true. Why? What is the reason that this particular 128205 is a 4 parasitic number? Like here x is n parasitic number, here this particular number is 4 parasitic number. Why this is like so? Let us try to understand. So first let me go to calculator and see, you just observe, see this number 128205 into 4 if you apply, and what is the value of multiplication? 512820. Have you observed any pattern? See, 128205, the rightmost digit is 5, which is coming in the front. So see, the number is 512820. Suppose you want to check for next case also, 179487 into 4. See, 7 is coming in front of the number which is the rightmost digit, and the rest of the same order, 1798948. Like suppose you check for third case, 179487 into 3, and see 538461. This is not following this particular input pattern, as I told, so this is not a parasitic number. You can check in Wikipedia also. See here, parasitic number, an n parasitic in base 10 is a positive natural number which can be multiplied by n by moving the rightmost digit of its decimal representation to the front. Like here examples is also given, like see this example, 4 into 128205 is equal to, see, 5 is coming in the front of this particular number and rest pattern is same, 512820. Okay, so 128205 is a 4 parasitic number. Okay, so we have to write such program which will check whether a particular first input number is second input number parasitic number or not. That is, this particular number 128205 is 4 parasitic number or not. So basically two inputs has to be provided. If you take input from the user directly, then also you have to write two inputs, like x equal to input enter the first number, y equal to input enter the second number. If you write in terms of functions, obviously you have to pass two arguments in that case, right? So what is the algorithm? See, first step is obviously take two inputs from the user, CLC, clear all, close all, warning of these things you can obviously write. Then x equal to input enter the number, y equal to input enter the second number, right? Nothing new. Now see, for parasitic number, obviously we have to multiply these two input number and we have to check, right? So obviously next step, do that whatever you have understood, that is z is equal to x into y. We have just multiplied two input numbers, so multiply those two. Now what we are doing, see, we are then what we are doing, we have to do circular shift of this particular first input number, and we have to check that whether the multiplication result is same with that particular circular shift or not. So what I am going to do, I will put all the digits of this particular first input number in one array first. Okay, then I will apply circular shift. So what I have done here, just see, make one array using the digits of the first number. M equal to x, as we define in case of digit extraction from a number, then y equal to define one empty array, then c equal to 0, that is c will basically, c is a variable which will store how many total numbers are there in the particular how many digits are there in their particular input number. Then while m greater than 0, b equal to remainder m comma 10, y equal to by. So we are storing that particular number in proper order, like suppose 149, if it is the input number by the user, then the array which will be created will contain first element as 1, second element as 4, third element as 9, right? Well, so that y equal to by I have written, but if you write y equal to like this kind of thing, if you write y equal to y, then b, then what will happen? First 9 will be stored, first element of the array will be 9, then 4, then 1. Okay, so better to arrange in proper order itself as input, so that by you just write, then c equal to c plus 1. So at the end of the particular execution, c will store how many total digits are there in that particular input number, first input number. Then m equal to m minus b by 10. This is for updation purpose, as you know from the digit extraction concept in MATLAB. If you don't know, please go through the link given in the description. And in this particular while loop, that's all. Then what we are doing, see here we have to, after multiplication we have to check that multiplication result digits are basically one time circular shifted of this particular first input or not. So what I will do, I will take this last digit to the front now. Okay, so for that what we can do, very simple, apply circular shift. The circular shift also I have discussed in detail. So create one empty array xi equal to one empty array, then xi of 1 is equal to y of c. This is what, suppose 140, that is 149, if y array is like this elements, then I have to do circular shift and I have to form 9, then 4, then 1, right? So basically last element is coming to the front. So x of 1, xi of 1 is equal to y of c. Y of c is the last element of the y array, xi of 1 is the first element of the xi array, so that we are equating those to keep the last element to the front. In kl equal to 1, this is just one variable for indexing purpose. Then for I equal to 2 to c. Why 2 to c? Because already xi of 1 is done. Then from second element to up to c, we have to store xi of I is equal to y of kl. So see, in the first iteration, xi of 2 is equal to y of kl. Kl value in the first iteration is 1, so y of 1. Then kl will be incremented by kl is equal to kl plus 1. Then again in the next iteration, xi of 3 is equal to y of 2. Xi of 4 is equal to y of 3, and so on it will go. So we have applied circular shift. Now what we have to do, see, from the concept itself you can say, see, we have done circular shift. Now we have to multiply that which we have already done, that is z is equal to x into y. X and y are two inputs. Then we will make one array of using the digits of the z, or using the digits of the multiplication result of x and y, and we will check whether this circularly shifted array and that particular that particular array which is formed using the multiplication result are same or not. Okay, so now extract the digits of the z. Similarly here make one another array using the digits of the z, that is z, where z is equal to x into y, we have already done. Same approach, m equal to z, w equal to define one empty variable, while m greater than 0, b equal to m comma 10, bw equal to bw, m equal to m minus b by 10 n. Now we have to check this particular w array is equal to this particular xi array or not. If those are equal, then only that will be counted as parasitic number, otherwise not. So what I have done, aq equal to w minus xi, that is aq is one array which will basically element by element subtraction it will perform, and it will store in aq elements, and g equal to 0, one counter I have taken. Then for I equal to 1 colon length of aq, if aq of I not equal to 0, then g equal to g plus 1. If this subtraction result for any particular element is not equal to 0, then we are incrementing the counter. But if any subtraction result is not equal to 0, that means obviously that is not a parasitic number. So that if g equal to 0 itself, that is whatever we have defined in the earlier stage, if that value only we are getting, then display yes, else display no. Very simple, right? So now let me show you the simulation in MATLAB. So see here, I have written the same program. CLC clear all close all, x equal to input enter the number, y equal to input enter the second number, z is equal to x into y, m equal to x, y equal to define one empty array, c equal to 0 1 counter, while m greater than 0, b equal to m comma 10, y equal to by, c equal to c plus 1, m equal to m minus b by 10 n. This particular loop will do what? First the c will count the total numbers present, total digits present in the particular number, and in y each digits will be stored. Then xi equal to one empty array, and in this particular part what we are doing, we are just making circular shift. Then in this particular part we are making one array using the multiplication result of x and y. Then in this particular part, see, in this particular part we are checking whether any element of aq, which is basically subtraction matrix of w and xi, is equal to 0 or not. If all the elements are 0, then display yes, otherwise display no. That's all, right? Very simple program for parasitic number checking. Evaluate selection. So let me show you the simulation. It will take bit time, so by that time let me check what is the input we can take. So this input let us try to take. So enter the number, and the first number is 128205. Okay, enter the second number is 4. See, yes, or you can write true also, no issue in that. Now let me show you for some more cases. Suppose let me take the third case, 179 487, and second element is 3. See, no, it is not a parasitic number. Now let us check for last case. Suppose let us give 179487, and next element 4. See, yes, it is a parasitic number. And moreover, I hope you have understood the algorithm, and then you can implement the same program using the functions also. Okay, the function code I will post in a link. That link I will provide in the description. Okay, some more test cases also I will provide, because suppose you want to make your own algorithm and solve this, then you can easily check whether your algorithm is working for all possible cases or not. So I will post all the snaps of the output test cases, okay, in that particular link also, so you can check. Thank you for watching.